Hello, I'm Logan, and I'm gonna explain how to type in an updated version of the launch program Mr. Herman designed for the TI-84 calculator. Now, his version only outputs the two angles that you could possibly get, but mine will output both of the angles, their maximum heights, and the time it took for them to land on the ground. So you start off, you have the original program, which you should already have written down, and there's a video Mr. Herman did of up to this point. You stop at opposite tangent of y store to z. Then we move on to the next step. So you're going to say alpha v cosine of theta. You're going to close that with two parentheses there. Store this number to h. Then you're going to type the same thing, but instead of theta, you're going to use z. So that's v parenthesis cosine of z. Close that with two parentheses, and you're going to store this one to I. That gives you your v of x value for your maximum range for your time. So you take this and you do range divided by your first value, which we should have set this to h, and that is again your v of x, and you want to store that to f, and then you're going to do your range divided by your other possible value, which we can store to g. Now, that's all you need to do. That gives you both of your time values, and we're moving on to the next step, which will give us our max height. We're going to store negative 9.81 to some character we haven't used yet. I'm going to use d, so that we have gravity somewhere in our equation. And you're going to say negative. You're going to close that with two parentheses, and you're going to say v sine of theta. Close this one with two parentheses. Squared divided by 2d. And actually, I'm going to go ahead and delete this. You're going to want to put this in parentheses. So divided by 2d. And store this to t. Now we're going to do the same thing again, but with z instead. So it's negative, that's two parentheses, our velocity, times the sine of z. Close that with two parentheses, squared divided by 2d. And store that to u. So that is all of the math. And now this is a very long section. It's quite important for all of the values to come out and for it to be easier to understand. You're going to go program over to input output and type 6, and that'll give you output, and we're going to do a lot of these. So output 1 comma 1 comma, then you're going to give yourself a quotation mark, and we're going to say ang 1 colon space, close your quotation. Then we're going to output at 1 8, and so these two numbers here describe where in the screen. So this p here is at 1 1, this colon is at 2 1. So this R is at 1, 2, and so on and so forth. It's just allowing you to put things at a unique place on your screen. We don't want a quotation mark there. We actually just want to put theta. That is our alpha theta there. That is our first angle. Then we're going to say 6, and we're going to put it in the next row. That's 2, 1, and we're going to say time 1 colon space and your quotation. You're going to press enter. You're going to do this program 6 at 2 9, and you're going to display f. Close that. Enter. Now, for the last step of our first value, we're going to put it at 3 1, and this is m. My microphone turned off. That's m height, or height, or mh, or whatever you want to put in there. Space 1 colon space, close your quotation. It'll move on to the next line, but you still have to press enter. And you can output at 312 because of how long this character is. And you want to output t plus, and then you're going to say alpha window, absolute value of s, and that is the absolute value of your um, displacement vertically when you start the cannon or where you land. The reason you need this is because this only gives you the height of, if it was on a flat plane, you need to add the absolute value of your displacement so that you get the total real height. Now we can move on to the next half with our second time and our second angle and everything like that. So that's going to be at 4-1. We're going to say ang2 colon space, close your quotations. We are then going to say, oh, not stat, program 6. I hate this thing. There we go. At 4-8, and we want to put in z. Now your next one, you're going to say programs over to input output 6. You're going to output at 5-1 time 2. Close that parenthesis. Program over to input output 6 at 5-9. You want to display variable g. And finally, the last one, we're going to output this at 6-1, and we're going to say m height or mh or whatever you want to put in for height. And then we're going to output at 6-12, and our variable was u, and then we need to add, that's alpha window for absolute value of s, close two parentheses. And for those of you who are not on a TI plus CE, the color version, you can stop here and your program is done. If you are on the color version, then you should add one more thing that'll make your program look and work a bit nicer. You're going to say program alpha math. So one more time, that's program alpha math, and that gives you wait. Then you want to, I'm going to say wait 2 seconds. You can make it wait 10. It would be forever, or 1, and it would wait for about 1 second. And so that'll have your program sit on your screen before your calculator moves on, and it makes life a lot nicer. We should be good to exit out. We can go program L. So it's asking for our velocity. There was a problem that we had before that I know the answers to, and the velocity was 30. The range was 87.1, and the displacement was negative 15. What we should get for our angles is something around 60 and something around 20. And if we get that, then the associated times and everything should be correct. We got 60 degrees and 20 degrees. Perfect. The time was 5.83 seconds. The max height was 49.49. For the second angle, the time was 3.09 seconds, and the max height was 20.42. And that's all correct. So thanks for watching. Good luck, and don't tell Mr. Herman.